So we are live.
Okay.
So let's see. We'll send out a BC again so we can have more guys to join us.
Okay.
We have about 5 people watching. Let's wait some minutes. People don't share that one with them. Don't share the one to join with guests. Don't share the YouTube link. Only for the. So everyone, thanks for joining in. We'll be starting very shortly. We just need more people to join. Um, if you're with us, you can just put any message in the put a chat emoji in the chat. Let's know you're ready to start. Um, so let's see while we wait for more guys to join in. I know we are already late on schedule, but we'll be starting very shortly. So if you're excited about the event, you can share a thumbs up in the chat. Okay. Yeah, we had some technical issues, reason why we started late, but we'll be starting the main event very shortly. Okay. Okay, so I'm guessing we have about 9 people watching. Without wasting any more time, I'll be going ahead to introduce our speaker. So, um, before we even go ahead to start our event, just want to have an quick show of hands or send a thumbs up to the chat section if you are part of the AWS Cloud Club's community, or if this is your first event, you can just give us a thumbs up. Okay, no thumbs up. Okay, DMBKG, I don't know what that is, but thanks for joining in. Only one person. I think Chinedu is joining for the first time. Shout out to Chinedu too. Daniel, shout out to you. Thank you for joining in. We'll be starting shortly. So while we wait, let me just go ahead to introduce our speaker. So our speaker is Badmus Anvoluwapo. Also on the call He's an engineer with over 3 years of experience in tech space, currently working as a platform engineer at TradeByte, where he builds and maintains internal platforms for the ease of development by product teams with a focus on using cloud native technologies like Kubernetes, Terraform, Agro CD, and other tools to achieve this. He attended OAU, so it's an it's our guy. Uh, and he also finished from electronics and electrical engineering with a bit of focus on communications engineering. He also has a background as a system administrator, network engineer, and developer. All this just one person. Occasionally speaks at conference like local hosts. Yeah, I think I was an attendee for that event where he talks about DevOps and general DevOps related topics. He's certified by a number of bodies, Azure, LF, that is Linux Foundation, Udacity, and many more. You can connect with him on Twitter and on LinkedIn. But I'm sure he's going to be sharing these links with you at the end of his talk. So join me as I welcome Badmus and Anvoluwapo. You can just send the clap emoji to the chat section. Okay, so Badmus, can you hear me?
Yeah, I can hear you. Hi, can you hear me?
So I want to say thanks for joining. Thanks for this event. I'm going to be removing my slides while you take over from here.
No, okay. Um, Let me share again. All right. Can you see my screen?
Yeah, let me see, let me see. Okay, yes, we can see your screen.
All right. Great. So, let's proceed. Then, thank you everyone, and welcome to AWS Cloud event. This is. It's nice to see you all, or have you. Even though I can't see you, have you all here. Nice to meet you all. Uh, if you can't hear me, just indicate on the chat so that I can make a quick change to my headphones if you can hear me, so we can continue. Yeah, let's proceed. So our topic today is deploying applications on AWS using containers, and uh, I know a number of us here are developers, and those that are not developers are aspiring to be developers. So for all of us here that are developers, uh, this talk will be useful for us, hopefully. At least you won't have wasted your 1 hour, 30 minutes, hopefully. So let's get to it. Who am I? Mostly things covered in the intro session. So platform engineer, I work at TradeByte. I also lead the DevOps group for AWS Cloud Club OAU. Certifications mentioned. So if you meet me outside and you don't know what to say, you are trying to start a conversation, you have to talk to me about Transformers, Harry Potter, Barcelona, Messi, Imagine Tech cars, basically. Those are my interests. And yeah, from there we can talk about anything else. So again, nice to meet you. So let's go right into it. Yeah. So our first, or I think because of the kind of topic we are talking about, it's a good thing to talk about code packaging. So what is code packaging? So code packaging is traditionally how softwares are distributed, or how they are shared, or how they are distributed basically among people. So traditionally, we've always had methods like using VMs. So VMs in this case are virtual machines. Virtual machines are, as the name sounds, they are machines that are virtual. I think that's the great thing about tech. Almost every concept that you're trying to understand what it means, the name is defining what it means, basically. So virtual machines are the virtual machines. They are machines that you don't have them physically, but you can interact with them in a number of ways. That's a very overhead definition, but I don't want us to go into the world of virtual machines because that's not really why we're here. We should talk about them. And then complete servers. So just to differentiate between virtual machines and complete servers. Complete servers are the old physical server thing that you can buy a rack, you can buy a very massive CPU, and then deploy your applications on that. Virtual machines are the ways you can convert those big servers into smaller chunks, which contains all the kernel or the necessary things to be a complete computer. But let's leave all that. You can also share them as disks, which I'm sure we're all popular, we're all familiar with as given our background. A lot of us played games that we bought from disks. GTA, most of your GTAs that you played, you bought them as disks packages. So I'm sure we are more familiar with that. So moving on to something that we really want to dive into is containerization. So containerization is the packaging of software codes with just the OS libraries dependencies required to run the code as a single lightweight executable. That's just a lot of talk. But essentially, containerization is supposed to help us package our software codes into really thin and short-lived, not maybe short-lived in some cases, maybe long-lived in some cases. But the most essential thing is to package them into really concise and non-mutable ways of sharing our code or sharing our application. So uh, let's give the best analogy for containers. So containerization is can be a funny term to explain because essentially we will be debunking some things about. There is always this argument in the industry about are Docker containers really containers because containerization in the view Linux sense is similar to this, but a whole lot more technical than this. So there is an argument that can be made that Docker containers are not real containers. Well, we're not going to the argument right now. So right now, we talk about why do we need containerization or what's the essence of containerization. So I think the most relatable description for it is the regular containers that we have on ship. So if we know very well, those of us that don't know very well, the containers that we see all around, especially the ones that fall from Ojo Elegba, that fall down, very sad things. But their real aim or their real goal is to sort of containerize and package things. Like they encapsulate goods, encapsulate whatever you need to bring in. So if you're trying to move product from somewhere to another, containers encapsulate them so that they can sort of be accessible and easily unpacked when they get to their destination. So that's essentially what a natural container does, which is not very different from what our containers here also do. So let's go. The format of our talk, I'll be sharing some slides, talking about some things, and then we'll have a very important demo session. So let's go. Introduction to containers. Uh, Containers, we've already discussed all this. Containers encapsulate codes and make them into single relatable files. So moving on, we'll be explaining more about with this particular image here. Uh, Please, I really have to go. Just a minute, Paul. Is Paul on the call?
Yeah, yeah, Badmus, what's up?
Okay. I sent you chat, please.
Okay. Uh, okay. All right, guys. So, our speaker just went to quickly do something and do something. We'll be back very shortly. But while he's away, I want to just welcome everyone once again. I also want to say, if you're just joining us for the first time, shout out to you. You guys are really amazing. Also, I want you guys to stick around to the question and answering section because we have AWS swags for you guys. So whoever is the most active or whoever is the answers the most question gets one. You get whichever you want. Either you want AWS socks, you want. You also have a pen that can help you to to that has a screen touch capability. Very cool. So stick around till the end, answer our questions, be as interactive as you can. Drop your questions in the chat if you have any questions. I'll make sure to read them out. So over to Badmus.
Yeah. So sorry about that, guys. Really had to attend something. Yeah. So let's continue. I was saying that we've described what real containers does, and now let's sort of compare them or juxtapose them or differentiate between what they are and how they function and the containers we're talking about. That is Docker container. So we already described that containers, they are used to encapsulate or package applications. So the most relatable thing is you as a developer, you write an application or you develop the basic application we all write when we want to start coding the to-do list thing. You write your to-do list application in whatever languages, Python, Go, JavaScript, Java, whichever one you prefer, or whatever choice you choose. So then you sort of write that and you have it on your system. This is working fine on your system. You can use it on your system. You can interact with it. Every route is working. Every HTTP request responds properly. But we know for a fact that for an application to function properly, because we're in the age where we use a lot of importing and a lot of building up on other people's code, you need to install a number of dependencies or a number of base file or a number of different binaries for the application to run. So you then need to share that particular application with a friend or a coworker or probably your boss or anybody. You need to send the same application to the person. Previously, what a lot of people used to do was they'll zip the file. I think they zip the file or move the file one way, copy it on a drive or on a disk, and then send it to the person. The person unpacks that, copies it, and just expect it to work out of the box. But a lot of time, what we notice it's there's always there's always a break between those two activities. Between the time you package it and the time you send it to the person, there's always a break in those kind of arrangements. So the most uh, the most popular cause of that break is the fact that there's a dependency you have that the person does not have. So every time the person wants to, so a lot of things happened to, or a lot of inventions happened in the tech space to sort of deal with that. People started using requirement.txt file, package.json file, so that when you so that whenever the person gets the file, the first thing you expect the person to do is pip install -r and then install the requirements file, or you expect the person to npm install the package.json file and all that. But all this that's just stressful. So if I'm somebody that reviews an application and I review 1,000 applications in a day, I have to install so many different packages that I may never use again after that particular package has been tested. So it's a bit of a problem for application packaging. Then some other advancements came where we started using virtual environments. I think Python people can relate more to this, where they use what do they call it, PyEnv, and then create different virtual environment for different use cases or different application. That also worked for a while, but we also saw that that increasingly became complex when you start having too many virtual environments. So containers sort of did something that solves all that problem for us. So for you to run containers, you have your server. So there's the term server is a lot of things to a lot of people. So let's just say you have your Linux machine. Let's leave servers. Let's just assume servers are okay. Servers Linux machine. Just relate it like that. And of course, I already specified as a Linux machine. That means your OS is Linux, or like they say, we should say correctly, your kernel is Linux. Your OS can range from many things from Ubuntu, Manjaro, Parrot, Kali, whichever Linux distribution you use, you have that here. Then you have your container engine. Now, this is one part that is a bit tricky, but we'll talk about it. Container engines are not just Docker. Docker is the most popular container engine that we know. It's basically because they popularized the concept of container. Containers have been a thing in Linux for a while, when we talk about namespaces and C groups, they've been a thing for a long time, but the popularization of them and making them a bit more popular, not even not a bit, very, very popular, started with the Docker group. So the Docker company made the Docker engine very popular to the extent that we now classify container engine to equate Docker. There are different container engines. We have container D, a number of them, but container D seems to be the one that everybody's flocking to now, mainly because it's used in Kubernetes. But yeah, we have a number of container engine, but for sake of simplicity and because most important thing we're trying to do is introduce us to this concept, we'll talk about Docker also. So the container engine we are talking about here is Docker. Now, if you are very familiar with containers, you need to sort of specify a base OS and then a number of different libraries and then your application. So these are what you will need to basically run a container. So I will introduce Docker in a bit. We'll talk of how does Docker help us to achieve these things. So we have two main files that we'll be talking about in Docker: Docker compose file, Docker files, and the Docker CLI command. They are the things that basically containers build on to really work for us. So all these are just a lot of theory. Let's move on to the main or to more interesting topics. So the most important thing is, oh, okay, yeah, I understand why containers will help me. They will help package my dependencies better. They won't, it's easier for me to share my packages with people after I containerize them. It's easier for me to they take less space, all the good advantage of containers. So how do I go about building a container, or how do I go about making one? So we already decided that we are using Docker as our main container engine. So that means I'll be explaining using Docker as a base. So the first thing is to use a Docker file. So I explained here that Docker files are basically they are keywords and instructions. They are like instructions, uh, like a recipe. That's the best explanation for them. So if you want to make something, a step-by-step guide to doing that thing, that's essentially what a Docker file is in creating a container. So Docker file is that recipe or that step-by-step guide that will help you create a container. And they are basically bash-like. So if you write a lot of bash or you are very familiar with Linux, you should not have issues with Docker containers. Even if you're not familiar, they are pretty easy to understand because they are relatable to day-to-day languages. So let's quickly go through this Docker file and see if we can understand or if we can. So by the way, this is not a unique Docker file. This was gotten from Docker docs, I think. Yeah, from the documentation of Docker. So just to keep it as basic as possible. Docker files can range from very basic to very crazy or very complicated. But this is a very basic code. Hopefully, we can all get it together. So first thing first is the from or from. So of course, there's an argument here that you can have an arg here. So arg is arg. You can have an arg before the from. But these are just for people that are trying to write really readable codes. Those ones are top skills you gain along the way. But right now, the most basic line that you need is a from. So what does the from does? The from does it gives us a base OS or a base image. So this will bring us back to the chicken and the egg argument. Which one came first, the egg or the chicken? You will say, okay, this is Golang package. How did they write the Golang package itself? So we can go through that vortex, but we are not going to go down that route for now. So from is our base image. So base images are their background or like the sound, their base images or their base containers or their base application that you sort of build on. So base images, popular ones that we use. We have Alpine. Alpine is pure Linux or what we call um, a base Linux, kind of the kernel only, the ones that uses the APK. We have Alpine, we have Ubuntu. You can base your Docker images off Ubuntu. You can base your Docker images off Node.js. You can base it off Java. But the fun thing about all those applications also is if you base it off Node.js, if you say, okay, from Node 16 or from Node, whatever Node version you want to use, and then you see Node dash Alpine, you will notice that what they eventually mean is that that particular node image that you're calling is also based on a Linux Alpine based image. So it's like you're cascading three different images. The node package you're using itself is based on an Alpine image. The Alpine image is based on some other image. So it's a lot of loops. But right now we are basing it on Golang. So this Golang itself is essentially saying, okay, we want to use Golang version 1.2. This Golang version 1.2 can be based on different things. If we had a lot of time, we can decide to check that. We can go online, check the Golang package repository because, of course, it's open source. That's the beauty of it. You can see whatever image is the base of this. And then you can also stumble on stuff called distroless images, but we're not going to go into distroless images for now. That's something we'll figure out along the way. Probably if we have a second session, we can go into distroless images. So from Golang version 1.2, we don't care where Golang is built from. We only know that this particular base image has enough capability to run any application that is written in Go. So any application that requires Go dependencies, packages that are stored in Go core programs, all those things are already encapsulated in this particular package. So we pick it as our from. We decide our working directory. Working directory is, as the name sounds, which directory do you want to work? It's not it's not so much of a big deal, but a best practice kind of thing. So a lot of people like to work from the SRC, which essentially refers to source. Some people want to work from the OPT, which is optional. Some people want to work from root, which is not advisable. Some people want to work from different kind of working directory, but of course, best practice is work from source. So please work from source. You are working from source. Now, this working directory is just specifying that, okay, all my application is stored in this particular directory. So whenever your application is starting or when you are sending the, okay, let's go, when your application says, oh yeah, it's time to start doing this work, the first place you check for all your files is that particular working directory, the source. Copy. Copy command is copy commands. It copies stuff. It's as simple as that. Don't overthink it. Now, for people that write Linux or people that work with Linux very well, you should be familiar with EOF, end of file instructions. This basically creates a file temporarily that you can copy or that you can use for any other thing. So this EOF thing, it is not a Docker command because, as you can see, it is not colored like the rest of them. It's just a regular Linux command, EOF. So it copies something from the host machine, which host machine is your machine, your Linux machine, not the container yet, your own Windows, Linux, Mac machine. So copies command from the source. There's a file there named main.go. Copies it. What is inside main.go is this package main, import fmt, print line. Do we need to talk about this? Maybe, maybe not. But basically, this is how you do hello world in Go. I know we've all done hello world in different languages, Java, JavaScript. But for Go, this is the most basic code that most people write in Go. So this is Go's hello world. You copy the hello world file in Go and put it in a particular directory, the source directory, which will be defined as our working directory. So you see that this is just Linux commands. So it copies it from your own host machine and puts it on the kernel, which on the containers you are building as a base from. So it is copying it from here and putting it on this your Go lang. So if you notice the way I'm talking about it, it is looking like they have two different machines and you are copying things from one to one. That's because that's essentially what it is. You are building like multiple devices, and then we call them Docker layers. But we won't go into layers of Docker files now because it builds them as layers. So when it's done with this layer, it deletes it or it removes it or it eliminates it, whichever line you want to use. So moving on, we go into the next command. This next command is run. Our basic, it's as the name sounds, execute, run. So this run is followed by a command, which most likely usually is a Linux command. But because we are in the Go environment, it is followed by a Go command. And this command is executed inside this our Golang, not on your local file, not on your local machine, not on your Linux, Mac, or Windows. It is executed inside this particular directory, the source directory. This one copies from your local machine. This one executes in your base machine, which is your Golang, so or your base image. I keep calling it machine. So Go build. Don't need to explain what Go build is. It's actually like your npm run or whatever. Not npm run exactly, but more like npm build. It builds a package. It builds an executable essentially. So it builds this executable called main.go, and it copies it into this bin.lo something. So now you have an executable called main.go. This is, I spent too much time here, but let's go on. This is the most important part of this Docker container building. We'll use it in a minute. So the next thing is, this is a double stage Docker build. So double stage Docker build is, you have two stages involved in your build. The first stage sort of builds the code, creates an executable. I'm sure we know what an executable means. Executable basically means a simple application you can run. So executables are all those files on your Windows machine that are tagged.exe, pest.exe, percent16.exe, which other executable are we familiar with? winrar.exe, all those executable files there, those are executable files. But in this case, our executable files are not .exe because we are not using Windows or .NET. These are Go executables. So Go executables are tagged with .go. So it copies this executable and copies it into this particular folder, bin/lo, and then run a cmd command for bin-lo. So this basically builds our Docker container. We'll be doing this by ourselves very soon, so we should not have a lot of stress doing this, hopefully, during our live demo. Not this exactly, but something similar, just something basic. So let's go on. Multiple containers. We are close to where we'll start our demo. Multiple containers. Now, you would argue that in the current age that we work, there's no single application that works alone, which is true. If you have an application, you want it retrieving something from a database. If you have an application, you want it caching something to a Redis cache, or you want it probably popping event from a particular data stream, whatever. So applications tend to work hand in hand or with multiple applications. So sometimes one application might require another application to run. One application might require three other applications to run. As the case may be, they vary. So Docker Compose helps us solve that issue. So Docker Compose helps you specify multiple Docker applications or multiple Docker images or multiple Docker containers to be run dependent on each other. So which means that you sort of want to build a sort of interrelationship between those Docker containers. So you are saying, okay, this is the web app, this is database. There is no point of the web app running if database is down. So you sort of write a database that depends on the web app. So you tell Docker, okay, check for the database or check for the web app. If this one is not running, don't start database. If this one is not running, don't start database. Don't start the next one. Don't start Redis. So there's a Docker command that does that. That's called depends on. And for Docker Compose, there are a number of different we say instructions that help you do this. So if we take a quick look at this Docker Compose, we have web. Let's say webs are basic Golang application that we built earlier. Then it builds it in the current directory, which is our source directory that we spoke about. Ports. Ports is the Docker container is running on port 8000. I'm sure we're familiar with port right now. Port 8000 or port 5000 or port 80 or port 443. So inside the container, it is running on port 8000. Outside the container, which is on my host machine, I want it to be accessible on port 5000. A lot of different instructions can be given here. You can port forward to multiple different ports. Volume, also, you can specify volume. Volumes are like, how do you say, they are volumes. They are like Zix-like kind of things. They are probably folders that you want to load into your containers. Okay, there's this folder that contains, let's say you are trying to process a video application, and then the particular video itself or the particular application you're trying to edit using a particular directory, and you want to load that directory into your code or into your container, you can use volume. Environment, you declare environment variable. I'm sure you're familiar with developing environment variable. Now, you see that underneath it, we have Redis. This is a new service or a new container. You can define its own images, its own everything. You can do that for as many that you want. So going on, now you've built your Docker container, you have your container package and you have it nice and tidy. It's there, it's about say 500 MB and it's on your system. How do you share it? The most popular way of sharing containers is using container registries, or there are different kind of container registries. We have Docker container registries, which is Docker Hub, very popular. We have Azure Container Registry. Also, that is, of course, as the name implies, owned by Microsoft, is for Azure. But this is AWS Container Registry. I'm talking about AWS Container Registry here. So AWS CCR basically means AWS Container Registry. So it's a managed Docker container registry. You use it to store Docker containers, and advantages of it is that because it integrates seamlessly with other AWS products, as you can imagine. So to pull from it to EKS is Elastic Container Service. ECS is Elastic Container Service. EKS is Elastic Kubernetes Services. You want to use it in code build. Code build is a pipeline application. They are very easy to integrate. You can just pull from there, push from there, very easy. So in Docker container, to use it, the steps are pretty simple. You create the repository, you authenticate, like everything in AWS. You need to show, okay, I own this registry or I'm permitted to use this registry. And then you can tag, you can push, we'll go through that. IAM policies would also look at that when we are doing our demo. So support CI/CD pipelines on and on. Next is deploying a container. Deploying the container. Now you have your container. You want to make it accessible to everybody in the world, or every person that you want to have access to it. There are a number of ways you can deploy the container. So don't forget now that your container is a fully blown application. It's a fully developed application for use. So one of the most common ones to use in the case of when you are doing dev testing or you are doing very basic deployment and you don't want to go all the whole, or I want automatic health checks, I want the application to be restarted a number of times, I want this, I want that. If you're looking for something very simple, the most basic one is EC2 instances. So EC2 instances are, yes, they are servers or they are VMs like we described earlier, and they are used to, they're basically Linux machines that are accessible over the cloud. Linux machines that you can give somebody an IP to and the person can reach it essentially. So why use an EC2 instance? It's very flexible, it's cost efficient. You can easily adjust the number of instances. It has pay as you go pricing. I think those of you that use AWS very well are very familiar with the cost of AWS. The cost is a bit steep because when the bill comes in at the end of the month, you know that you're paying for something. So with EC2 instances, you can manage your pricing better or easier. And then you can also fully configure your server. You can decide what to store there, what not to store there. You can decide, oh, the GUI is not necessary. I want to delete the GUI. You can decide, oh, I don't need the instance to have LibreOffice. Is it LibreOffice that comes with Ubuntu? You want to delete it. So you have a good number of configuration, full control over the configuration of what is contained in the EC2 instance. So how do you do that? You can launch the instance. We'll do all that, don't worry. So it might look like we're closing, we'll do all that. Launch the instance, install Docker on the instances, pull your container, run your container, basically make it accessible. So uh yeah. Yeah, I think we have enough time for our demo. So I think this is the fun part. So I was hoping a lot of us would join with our system so that we can follow along. But I'm not so sure how we will do that right now. But I will share with us something that can really be of great help to you. So, of course, if you want to learn more about Docker, like I said, this is a very basic foreground for your continuous learning. So, this is the link to a playground. I don't know if this is shared with everybody. I think it is. So, you can go to this link. It has a pre-built terminal, a pre-built editor, and then you can basically sparse. Yeah, Paul has something for us.
Yeah, I just wanted you to send me the link so that I can
Okay.
show it on
Um,
the screen here.
Let me share with you. One moment. Yep. Did you get it? Hello?
Yeah, I got it. I'm sharing it now.
Oh, okay, great. So I'll stop sharing my screen briefly so that I can share my own screen and then we can sort of just do a demo. I'm hoping that the demo will not take us so much time and we can have some time for question. So
Yeah, okay, that's
just a minute. So I really would like to know if some of us are actually following along so that we can probably offer proper support for you, or if you're just watching my screen. Because if you're following along, there's somebody in the chat that can really help you.
okay.
If
So, if you can signify in the chat if you have your system in front of you and you are following along. Okay, so Shafi is following along. Uh, any other person? Okay, so we have two people now, three
okay.
people. Okay.
So, yeah. So for those of us that are following along, I believe you can see my full screen now. Is that right?
Let me see. I'll show it. I'll add it to stage. Okay, they can.
Yeah. So you should be able to see my full screen as at now. So this is a Docker playground. Essentially, Docker is like most application that you know. You have to install it some ways. So to install Docker, we'll discuss
Uh,
that later.
Badmus, can you? Is there a way you can zoom in,
Zoom in. Oh, sorry, I didn't really consider that.
to make it more visible?
Um,
I think. Okay, yeah, yeah, makes sense.
yeah. So, nice. So most times, if I was saying you should use your own system to start installing Docker, that can sort of impact our progress. So this playground can be used to follow along. It already has Docker installs and some of the important packages. And if you need any other information on Docker, this imox.com has some of the not some the best Docker resources you might need ever. But it gets a bit technical, so you might want to learn the basics first before going into it. But really great. The owner is a guru. That's a fact. So if you click Docker, if I press Docker, oh, okay. So this basically shows us that there's Docker installed on this. Yeah. So also the cool part is it has this ID thing. A minute for it to load. And let me sort of reduce. I think I might need to reduce this a bit. Yeah, hopefully you can still see it.
Yeah.
But this is an ID very much like VS Code, but it's in dark mode because I like dark mode at least. You can change it to white mode, but then you might attract a lot of bugs. You can't say. So let's move on. We have the first thing, like we said, is our Docker file. So no, I won't be writing Docker file from scratch here. I'll be copying and pasting, but again, and yes, ChatGPT wrote this Docker file. I know you're about to ask, but it's a nice Docker file and it does our work for us. So let's look at it. Let's look at it more closely now that we are here. So this is a Docker file. Like I said, the form is our base image. It basically, so if you follow this link, it will take you to the base image that you can see what it contains. So our base image is Nginx. If you know what Nginx is, I think. So if you don't know what Nginx is essentially a web server that you can use to serve your application. So this is Nginx, and it is using the Nginx official image, as you can see, as our base image, and pulls the latest. Latest is the newest and shiniest. So exactly. The next thing is an HTML file. The HTML file is basically our application. the code you write, your npm packages, your npm something. Oh, sorry, that was not supposed to happen like that. Sorry. So index.html basically, of course, I'm sure we have a lot of senior developers here. You guys know what index.html means. It's basically index.html. Your first website, your most easy website. Let's put it like that. So this index.html, it's a very small website. Yes, ChatGPT wrote it, as you can imagine. But as you can see, this is just the small. Let's say this is a small application we want to Dockerize or want to deploy. So another thing to put here is our Nginx config file. If you are very familiar with Nginx, you know Nginx needs a config file. Config file basically tells Nginx how to behave, what to do in terms of problems, what is the allowed route, what is not allowed. So it
Okay,
defines
so
this.
Badmus, I just got a comment in the comment section. Someone
Mhm.
is saying you are too fast.
Oh, I'm so sorry. I'm
Yeah,
trying
so
to beat
I don't
time.
know how many people think. If you think you should slow down, you can send an emoji to the chat section so we know
Oh,
um what pace you should go.
yeah, I'm very sorry for that. I was trying to beat time.
Yeah. You can just slow down it in a bit because
Yeah,
we
all
also
right.
don't have much time. But also note down your questions so that once we have time for questions, we can take all of them at once.
Yeah, all right. So for the person that could not follow, yeah, you need to sign up on the playground, but the sign up is really easy. You just need a GitHub or a GitHub profile. So once you go to the iMux thing, it will ask you to sign up. And once you try to sign up, it will tell you to link it to your GitHub. So just link it to your GitHub. It's straightforward. Yes, you need to sign up. So also, if you don't want to use your GitHub, it's really cool. You can also just use an email and a password. Very easy. Do you want me to hold on to you sign up on the playground? And for those that are asking for the file, yeah, I can share the file. What's the best way to share the file? Um,
Maybe a Google Drive link.
oh, okay, so let me just do that real quick.
So while he's doing that, try to set up
So try
some.
to sign up. Try to
Yeah,
sign up while I'm doing that. While
so
I
yes. In
do
the comment section, it's saying the ID is not loading.
the ID is not loading. Not really sure. It's loading for me. Don't load. Don't press the two arrow thing. Just click on ID beside it. If it's not loading, you can cancel it and try it again. So let me quickly create a new folder. Um, Cloud Club, and then let me just drag some of these files here. Mm, nope, 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 nope. Oh shit. Mm,
I think I see where people are having issues. I'm trying to I'm trying to load the page, but it's not coming up. I'm
it's not loading.
guessing yeah. So I'm guessing location may just be the issue. Uh,
Oh, that's bad.
so yeah.
Oh, sorry. What browser are you using?
Okay, it's coming up now. So I'm
Yeah,
guessing
just
maybe you just need to keep reloading.
yeah, it comes up. I don't know. I think
Which was
probably
like
might be an MTN related thing because I know I used it for a long time also while I was around. So I don't
okay.
think I don't think it's location issue. But
Let's
for this one, let me share this with you. I think a lot of people are interested in the demo, so I will try to
yeah,
slow
so
down.
what we can do is we do the demo and since it's a YouTube live stream, you can always go back and stuff like that. Then we ask questions and try to round up first.
Oh, okay,
Then
okay,
any
okay.
other issue we can solve after. So like just walk through the demo in a not too fast pace. Then we can just take
All right. I'm sharing my WhatsApp to the world. God. So yeah, I've shared the link with Paul, and yeah, you should have that link. Are you ready?
yeah, you can go ahead.
Yeah, okay. So back to the playground. Like I said, we start again, just so that we can all follow now. There is the base image, which is Nginx. The next file, like I said, I think in fact we'll just be using VS Code so that you can sort of pick it up on your own, is to copy file from source to destination. So it copies it from source. Source is your PC, destination is your image. Don't forget, source is your PC, destination is your image. So in this line, I am copying index.html. Index.html exists here, or it is in my current working directory. So it will find it. If it was some other place or if it was in some other location, I'll have to do some random thing here or some random location until it gets there. But index.html is here. I can also just do like this, specifying current directory, then index.html, whichever one you're convenient with. So source copies index.html and copies it to user share nginx HTML index. The reason for this particular link, if you're familiar with nginx, this is where nginx stores HTML files that you want to serve locally. So you can serve files dynamically or locally. So if you want to serve it locally, this is the location for doing that, which is why this is there. I've also shared the link with Paul for the files. I'm not sure if we have it. Do we have it?
Yeah, it's in the chat,
Okay.
but the long link, so I don't want to display it on the stream. It's in the chat if
Yeah.
you
Okay. So if you want it, the ID is given 502. Not really sure about that, but I think I'll finish the stream and I'll be around for 15 more minutes if you want to troubleshoot whatever you are going through. Happy to
can.
help. So then next thing is our nginx. Of course, we know what is contained in index.html. Next thing is our nginx.conf. Nginx.conf, like I said, contains instruction on how nginx behaves as a web server. So listen, the listen command basically does exactly what it means. It listens. It is always listening, always waiting for connection from external users on this particular port 80. Server name localhost is 127.0.1, which is our localhost IP. This is the domain name that localhost that particular IP address resolves to. Should we go into server name? No. There's a lot more to discuss on server name, but we'll come back there. Location roots. So this is, if you notice, this is where we stored our HTML file. This is essentially just having, or the folder we store our HTML file, and then index.html is basically served from that same location. So basically, a lot of other things can be included here, like proxies, timeouts, and the like. Well, those are things we'll pick up as we go. So we've spoken about all this. Now, let's quickly do some really interesting trickery. It's not really trickery, but I think it's so. I wrote a script to do a quick run of that thing so that we don't have a lot of back and forth. Sorry, I keep missing my tabs. So let me just call it scripts.sh. Sorry. .sh just means shell. It's just a shell script, nothing too serious. So what does it do? It encapsulates two Docker commands, which is our Docker build. So the next stage after you've written your Docker file, or after you've completely defined all what you want your Docker to do, is to have a Docker build. The Docker build is the instruction that tells Docker, okay, Now you can build this image. And then Docker run is, of course, it makes it okay. Now you can run the container. So keep keep note that the image is the instructions, while the container is when the image is running. Just some technical thing for you to remember. So let's look at Docker build command. I wanted to run it as a single shell, but I think it will make sense for us to run it separately. So let me paste it and run. You see that the first step here is it does three things. It pulls from docker.io, which is a Docker registry or a container registry, pulls the base image, and then so the base image has a bunch of layers. It does all that. The number of layers, it pulls all that. Then you see that the next thing it does, I'm not sure if you can see it very well, but it's copy. It copies, it's executed our instruction to copy. The next thing it does is execute our second instruction to copy nginx.image. So if you look at the ID and you look at our Docker file, we have two copy commands. It copies this and it copies that. Now, expose. Expose is essentially saying this container should be listening on port 88 plus 80 or port 8080 or port 2000. There's an argument for you not to use expose in your Docker containers for security reasons. We can go into all that, but that's not our aim here. We're just trying to build a Docker container. Now, environment variable, you can also specify environment variable in your Docker image. It can be anything. So I'm just going to change the environment variable to be my name, of course, Badmus, and then this. So if you noticed, I've already built the Docker container initially before I changed some things here. So after saving this file, I can just rerun it again, just run that command again. You see, it's faster now, considerably faster. Why? Because it did not have to pull this image again from scratch. It saves it somewhere in your system and just reuses it. So now that we've done that, so the nice thing to do would be to run, probably to run our Docker build, but that's not our aim. Our aim is to store this in a Docker container registry. So the Docker container registry we are using is ECR. So I'll reload this. This is my AWS account. Please don't spam me. In fact, you can't even spam me. You don't have access. So this is the registry that we created. This is the registry that we created. Now, to create the registry, it's quite simple. You can just go, once you log into your AWS account, you do create repository. You have the option of picking between private or public repository. Then let's say I pick this 2. I like private repository because it essentially means anybody that is pulling or pushing from it must be authorized or authenticated to AWS using IAM. So it's more of a security feature. You can also make it public. Public essentially makes it easy for anybody to pull from it. So I have a public repository, but I can also push to a public repository and then have anybody pull from it. So it's just, do you want it to be public? Do you want it to be private? Just your decision as the engineer in charge. And then scan on push. This essentially means there's sometimes when you build security vulnerabilities into your image, or probably you use, if you are very familiar with how security thing work, you use a particular, how do we call it now, dependency that is exposed or that is vulnerable. So if you turn on this, AWS will automatically scan it for you and will tell you, okay, this particular report, this particular image has an issue, or has this, or has that. So you can also encrypt a bunch of things. So I'm not going to create a repository, obviously, because I already have one. So inside this one, as you can see, I already have an image here, which I tag latest. Because I've not scanned it, you see there's no vulnerability status here. There's no scan status because nothing is going on. So now you have your image here. The image built from this place, you have it here. So you can now go on to tell somebody, oh, now I have my image. You can pull this and you can test. You can do this and you can. So anybody that has Docker can just run this and will not need to install dependencies. Will not need to ask you, okay, After installing Python, what's the next package? It doesn't need all that, just needs this image. And as you can see, it's just 70 MB, which is
Badmus, can you zoom in a bit?
okay, which is pretty small as they come. So is this fine?
Yeah, I think this is better.
Okay. So the next step will be to run it on EC2. So this one I've not done before. So not I've not done before ever. I've not done it. So I would like us to do it live. So there are a bunch of different ways to run a new instance, and there'll be a lot of unsecure stuff. But I mean, that's the fun of it. So AWS Cloud Club. That's the name of our. Now, do we want to use Amazon Linux or do we want to use Ubuntu? Let's go for Ubuntu. Ubuntu is 50 eligible because I don't want to be charged so much. We are going to use T2 Micro. Keep here. Yes, create a new keep here. Yes, create keep here. Test. So this is keep here is how you keep here is SSH key that you need to log into your server. So it's like a password rather than using your password, or your name and password as password. It generates for you a key that is really long and really difficult to guess. So it generates that. Of course, security-wise, it's not right to put it in a default subnet and all that, but we are not really talking about how to host the C2 instance. So let's just go. Allow traffic, allow SSH from anywhere. All of this is fine. Launch instance. Let's go. Yep. So if we've not broken anything, this should work straight. So we are in a pending state. It means it's creating our instance. So while we are doing that, I'll quickly explain what just happened. So we created a Linux machine in the cloud. So the Linux machine we created is Ubuntu typed, and it is stored in AWS, or it is owned by AWS. So based on how long we use it, we are going to get charged. So essentially pay as you go. We have a public IP address that we can give to people. And the main reason why we are doing this is because we want to be able to run our image here. So I will also use EC2 Instance Connect so that we don't have issues, so that we can easily go through it. Now, our workflow is like this. You've built your image as the developer, you've stored it in your nice ECR registry, or if you don't want to use ECR registry, you store it in your Docker Hub or wherever you want to store it. Now, this is your friend's system, and your friend wants to run that image. We're going to see how quick and easy it is for your friend to quickly achieve that. So, of course, one thing your friend needs is Docker, because what he's trying to run is Docker. How do you install Docker? I really do not know. So, like what everybody does, Docker install. So I don't want to install Docker Desktop. I specifically want to install Docker Engine. The difference between Docker Desktop and Docker Engine is, we'll talk about it if we have time. So this is how you install Docker. You come here. I also don't know the command offhand, so I just come here. Docker Desktop. No, I don't want to install Docker Desktop. Come on. Also, if you want to take my word for it, if you trust me enough, you can just do apt install Docker. Of course, sorry, you need sudo. Does not do that. I think it's Docker C. Not Docker C either. That's unfortunate. Docker Engine. Install Docker Engine. I really want to install Docker Engine. Yes, it is Ubuntu. I thought I saw Ubuntu, right? Yes, it is Ubuntu. Of course. So this is the command to install Docker Desktop or Docker Engine. So what do? I copy that. I'm basically trying to show us how long it's going to take for somebody that has not installed Docker before to have Docker set up and running in, let's say, a server or on their own local PC. So the first stage we are trying to do is install Docker. Sorry, my network is shit. Yeah. Pulling stuff. So those of us that are not familiar with Linux so much, what it's essentially doing is do I need to explain this? No, basically just trying to install a Docker. That's basically what it's trying to do. So, yep, let's do this. This is fun. Mm, 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 mm. What do you mean Docker desktop does not exist? Mm, mm, mm. Are you telling me Docker documentation is wrong? Mm, 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 mm. We use Ubuntu for everything so that Linux meant instead of code name. There is a problem. I was hoping we won't have problems, but again, this is software development. There's always problems. Yeah, okay, sorry. I did not do sudo apt updates. Yeah, sorry about that. No. Yes. Did I not answer yes? I did answer yes. Come on. We have less than 15 minutes to go. So while this is installing, probably you can start pasting your question on the chat so that I can just. I have Docker desktop too. What made you use? What made you made me call? What is really different? Oh, okay. So Docker desktop is. So let me just do this. This is Docker desktop. I'm sure you can see my screen. This is Docker desktop. It's a whole application. It has a number of things really. Learning center. You can add extension. It's it's the bigger brother of Docker Engine. Docker Engine is, if you strip Docker desktop of all the whole fine piece in the interface, all the extensions, all the main thing that does the running of the container is Docker Engine. Docker desktop is just the glorified one for corporate bodies. So Docker desktop is fine if you are using it on a system that is yours or that is GUI enabled, that you have a web interface or you have a GUI interface and you have a lot of space. So when you have space constraint, or you are trying to optimize for speed, or you are trying to just do a proof of concept kind of thing, you want to go to Docker Engine, because Docker Engine can only be interfaced to its CLIs, basically. That's the difference. I hope I answered your question correctly, sir. Yes, so we have Docker is done installing, and then if I do Docker, we see that there's Docker on this computer now. Great. So we have Docker here now. I can just do a Docker pull. This is the ECR. Oh, sorry. Yeah, this is the ECR. Yeah. So this is the image you want to pull. So if you don't know what to do, if you click on this, and you just show push command to show you a number of commands that can help you push things. But you're not really trying to push, you're trying to pull. So you can just copy this URI. Where is it? Where is it? Where is it? Where is it? Yes. Also, oh, okay. More importantly, um, because this is a private repository, you need to authenticate. That means you need to show that you're part of the people that have access to this. So one thing would be to log into AWS. The best way to log into AWS is to have a CLI. And of course, with AWS CLI, it allows you to a myriad of things, which is more than Docker. But in this case, it's really our best option in logging in. So I really hope we understand most of what is going on. So previously, what I did was install Docker. Right now, what I'm trying to do is authenticate to AWS so that I can have enough permission to pull. Because, okay, probably I should even show what will happen if I try to pull without authenticating. If what you're deploying is a monolith, do you have to use Docker Compose, or you can just write a Docker file? If you are deploying a complete application, like a really big application, whether it's a monolith or microservice, I would advise you use Docker Compose. Why? Docker Compose, Docker Compose has some inherent features, or not inherent, but some flags you can specify that will really help you. So things like always restart. So it will, if your container goes down, or you have, let's say, a sick queue queues whatever command is running in your container, or some unexpected thing happens, with Docker Compose, you can start up that container easily without so much stress. With Docker Compose, you can specify some networking, some level of networking, that is. So you can specify, okay, you want to map the Docker internal IP to this particular domain, fully qualified domain name within your LAN though, and it will work. Well, with just a Docker file and just a simple Docker run, yes, it will run, but you are not failure proof. And as SRE engineers or as DevOps engineers, our goal is always to be failure proof, ensure that okay, we are we are protected when something goes down, or we automate as much, or our computer tries to help us as much as possible before we actually have to step in. So use Docker Compose, except you don't have an option. So I hope I've answered your question. Sorry, my system is about to die. Let me just quickly plug it in. 5 minutes. Uh, but you will still hear me though. Oh shit. You notice that notice started with the ECR followed by the EC2 instance. Can you elaborate the difference between the role you play in Docker container? Oh, okay. So I'm sure you can hear me. The difference between the ECR and the EC2, the ECR essentially stores the repository or stores the container, while the EC2 is just a server. So the ECR stores, EC2 is just a server, essentially. Um, yeah. So you might not see my face as often going forward, but I'm still on the call. So let's just continue. AWS CLI. I'm sure you can see my screen. So I'm trying to log into AWS, and then I do AWS configure. So AWS configure basically does what we know as essentially log into AWS. Of course, I'll be sharing my screen on the internet, but trust me, I'm going to delete those keys very soon. So this is your access key. How you would generate this, I think this demo might take us a long time. So Docker Desktop is bundled with Docker Engine. Yes, correct, sir. Docker Desktop is bundled with Docker Engine. It is part of the Docker Engine. Or the Docker Engine is part of the Docker Desktop. Oh, shit. So I'm trying to log into AWS with AWS configure, and they asked me to provide my ID. So let's grab the ID real quick. Moderator, I think we might run a bit beyond time, so just begging in advance. I like the way the questions are coming right now. So
Yeah,
which are
reason
the
why I'm just like putting them on the screen when there's time, so you can squeeze out one or two questions while you're doing
okay.
what.
I noticed you didn't use the working directory keyword in your Docker file. Yeah, so because the Docker file I was trying to build was very simple, it's just a single file, and the single file needs to exist in a very special directory, which we didn't need to define. That is, and because we already defined it in our nginx config. So I will navigate there in a minute. Access key. Okay, let me just paste the access key. So I'll navigate to the working directory issue now in a minute. Let me just try to quickly log into this. Yeah, default region. I'm not using US. EU Central. I think that's Frankfurt. EU Central 1. Yeah, that should be Frankfurt. Output should be JSON. So I don't know, but my screen is clogged up. AWS is running riot with my device. Okay. Come on. So let's pivot. Like I said, let's pivot. Now, you've built that image, you've pulled your Docker container, can you explain more about Docker registry and its significance? Okay, so Docker registry and its significance. Docker registry is take it as an hard drive that is a shared hard drive. So you have in your company or in your workspace or in your place that you work, you have a lot of developers working consistently on different applications, and they want to deploy the applications to different EC2 instances or different servers. Then you have one particular place that you store all the images that are built. So you just say, okay, this particular system, whenever you finish building, just push it there. That is what Docker registry is. So let me just show us something very important. So if you can see my screen, you see I'm going to Docker Hub. So this is Docker Hub. It is the largest container registry in the world. Hopefully I'm not capping. If I am capping, you'll find out later. At least you won't find out on this call. So this is Docker registry. This is a registry. This is the most important Docker registry. Now, when I say this, when you ask about the significance, this is the significance. You see that Alpine, which is where we build where we base most of our images on, they have a Docker hub here. They have a registry here. If you open Alpine, you will see a lot of images. So if you can, I don't know, there's no way to see all the ever created tags in Docker, but these are all different tags that have been created for Alpine. Same thing for all your popular providers. So if you want to build an Nginx image, this is an Nginx image already here. If you want to use Ubuntu, there's already Ubuntu. If you want Python, there's already Python up. So this registry stores all the different images that you want to build. If you also navigate to Badmus, I'm coming. Badmus, I know cubes. Yes, this is me. So even you that you are a personal person, you can decide to create an image and push it to this registry. So this is one of my images that I used for K8 practice a long time ago. So you see cubes, you store every images that you build. So Docker registry should store images that you build. So this is one kind of Docker registry. This ECR is also another type of registry. So it is essentially to store images. That's all. I hope I answered your question. Yeah. So not to delay us much, we've really gone beyond time. Now that we've sort of built our image, we stored it in the Docker registry. To store it to the Docker registry, let me just show you that, and then we'll go into viewing the image itself. If you view push commands, now this is very important. You see, the first thing here is login, retrieve authentication. Documentation are the best way to learn. Retrieving authentication, that's not a big deal. That's essentially telling you how to log in or how to gain access to your AWS registry. The most important thing here is how to tag these images. So if you notice that there is a command docker build -t. -t means to tag an image. Tagging is essentially naming your image. Okay, this is the name I want you to call it. So let's do something real quick. If I do that same thing here, Docker build. Sorry, I know this is very small. How do you expand things on this thing? That's one I'm not familiar with.
I think that control plus
Oh, Control Plus is not doing it.
it was not working. I
Uh,
usually use okay. Let me quickly find out the shortcut online.
mm. Let me just find it.
Okay,
Expand.
control plus equal to
Oh shit. Okay.
does that work?
It works in some ways. Let me see. It works as it brings up Windows magnifier, which is not what I want.
Okay, okay.
But I think that works also. Let's just continue.
Yeah, that
So I'm sure you can see what I'm typing. So I'm doing docker build dash t. Dash t is the tag. And then I say, let me name it nginx. And then I want to nginx tests. And then I say version 2. The full stop at the end is specifying our specific place that our Docker file is. So if your Docker file is stored some other place, you have to put location of your Docker file here. Hopefully you understand what I mean. So full stop is just saying, okay, our Docker file is in our current directory. You see that it builds it. Now we have our build. What next? You want to push it to the registry like we described. So if we go back to, so if I do Docker, oh shit. If I do Docker dash, Docker tag, no, this magnifier is really a mess up. Let's just go back to the normal thing. So now I'm trying to push to this place and I've built my image and I want to tag it. For you to push to this particular registry, you need to tag it very specific. So to specifically tag it to come to this directory, you need to tag it in this method. So Docker retarget the all fully qualified domain name of your registry, the name or the long name that AWS provides to you, and then specify your, how do you call it, your name or your special name or your own made name. So let's do that. I'm basically just doing what Docker something says. I'm sure you can't see it, but just take it down. I'm telling you the truth. And if I lie, you can try to zoom in some other time, catch me and drag me on Twitter. So Docker tag this, and then you can just copy this. This particular name is very important because that is exactly where we are trying to push to. So you see that I copied that, and then I just tag it again. So I specifically renamed it. The renaming makes it, how do you say it? The renaming makes it easier for Docker to push it to the right place, because if I don't specify that long name, it would think that it is something meant for Docker Hub. So to try to push it first to Docker Hub, but because I'm specifying that it is for AWS private registry, it is going to specifically push it to that registry. So if I do Docker push, so if I do Docker push this whole long name that I made, sorry, I can't type it again. You see that my authorization has expired. So I'm already logged in before, but my authorization has expired. So what do I do? Let me, this magnifier is just a mess. Please, who can help me with how to expand things on VS Code? If you have the command, please help me. Yeah, this is how to get the authentication. Authentication is essentially password. What gives you the right to push to that particular repo? That's what authentication is about. So I get my rights. Login succeeded. I don't know if you can see it, but it said login succeeded. And now I can push. Retrying. Why is it retrying though? Something going on. Probably calling the wrong name. So let's just authenticate again and then we push. Docker push all this. Well, the aim is just to show you. So let's just do this again. Let's use this is the previously built image just for you to know. So this is how you push Docker push, then the long name, and then it has what previously. I just pushed the previously existing image because I can't wait for this. Our time has really gone. So we've shown how to push, how to build, how to push. So once you push it, you should be able to find it here, which is your latest. So last but not the least is deploying it. You're supposed to deploy it in an EC2 instance, but time has really gone and before they kick us off the stream. So let's just do something really fun. I'm just going to run this. I'm going to run scripts basically. So the second line in this script.sh, you will see that it is Docker run something, 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 something. So we'll quickly look at what Docker run does and try to describe it. So what does Docker run do? See, Docker run is going to run that particular image. -D is going to run it in daemon mode. Daemon mode is background mode. Let's put it like that. It runs it as background so that it doesn't clog up your screen with logs. -P specifically specifies the port. What port are you forwarding from? What port are you forwarding to? So I'm forwarding from port 80 inside my container to port 80 on my host machine. The name of the container and the new name I want to give it, the name of the image and the name of the container. If I run it, it creates for me a container. Of course, you can't see it here, but let me just show you. Allow public access. Let me do port 80. Get the link. I hope I can share the link on the chat that you can see. That is going. Why that is going? Let me just share it here. Upstream disconnects for whatever reason. Retry last with a good examination. What is going on? Index localhost. Oh, looks like scripts.sh. Okay, let's do this. Stuff slash. So if I do docker ps, I think this is even a good naming thing for us. Docker ps-a. This will lead me to all the Docker containers. So you can see that the container crashed and exited. Docker ps literally lists for you what is going on in the container. And this has exited for whatever reason, not clear to me. I'm not about to debug that right now. So I will just run scripts.sh again. Okay, script.sh is not yet chmod 777. Scripts.sh. Then I can run scripts.sh again. Load sets. You have to rename that container to be able to use it. Okay. So let me just docker kill something. So docker kill is a method to kill whatever container is currently running or whatever image is currently running. Docker kill or docker stop, whichever one you want. So docker kill kills it. Docker stop stops it. Docker rm removes it. So docker ps /a copy docker rm. That basically removes I was hoping we'll be able to do this inside an EC2 instance. Now that we have that remote, we can run our script again. Yep. Now let's see. Port 80, get link, run that. No public access. Mm. Oh, we copied something wrong from our index.html file. No, from our config file. Yep. So we forgot to copy something correctly, which is causing our problems. So we'll go back there and we'll fix that. Where is it? Paste. Yep. So our engineer config file was wrongly copied. We will fix that by removing this. And then running scripts again. Yep. Now we should have this. So if you are doing this in an EC2 instance, you should not have to go through all this method, but yep. So this is our website running fine and running. So in an EC2 instance, something similar, you install Docker and you do a Docker run. That's all. So this has taken considerably longer than we expected. Sorry about that. But yeah, I think that is it. So do we have any questions? Let me stop sharing this.
So thanks a lot, Badmus. You've conquered Docker this evening. So
Hopefully.
yeah, I'm just going to go through some of the questions we have. Uh, the questions. Okay, let me see. There was one I started. Okay, someone is saying, I know this is basic, but what are you referring to as an image?
Oh, okay. Sorry, there's nothing basic. Oh, ask any question. So an image is the application that you've turned to a a container, but it's not running actively. I don't know how best to explain that. So just let me share my screen again. I think the best way to do that, share my entire screen.
I'll have to add you.
Okay.
Okay.
Yeah. So I'm not sure if you can see my screen, but this is an image. All of these separate things are images. They are they are not running, so they are image. But the moment I do run like this,
It becomes a container.
it becomes a container. So this one running here is a container, but these ones that are here not running, they are images.
Okay. Yeah, so to just put it lightly, a Docker image is a standalone executable package that
Mm-hmm.
includes everything you need to run a software.
On the
So it's
software,
just,
basically.
yeah, it's executable. Once you execute it, once you run it, it becomes a container.
Mm-hmm.
So let me move on to another uh, uh, two
Oh,
questions. Shafi has two questions. You can drop them in the chat. Let me see. Let me see if I skipped any question. Did you answer this question already? This one on
yeah.
okay.
So this is the person I was looking for. So the person asked why we didn't use a working directory. Sorry, Paul, can you add me again? No, stop sharing again.
Okay, so I'll do that now.
Yeah. So you asked why we didn't use working directory. So if you see, okay, this is not really clear. How do I make it clear? Okay, can't do this. Yes, smooth. So if you look at this particular Docker file, there is no working directory like you said, but we copied our file to this specific directory that we want to use, and then we specified that directory here. So this sort of ensures that all our incoming request is routed through this particular line. But most of the time, or sometimes, you don't necessarily have to use Nginx every time. So in cases where you're not using Nginx to define where your source directory is, you can use working directory. But also using working directory here also will not hurt.
Okay, so let me move on to. Uh, I don't know if Shafi is still on the call. Shafi wanted to ask a question.
Okay, please ask.
Um, okay, so okay, let me see. Let me see. No other questions. Guys, you guys should bombard Badmus with questions. Is in his elements at the moment, so you just will
Uh,
answer your questions as soon as you drop them.
okay, AWS has decided to give us back our access. It's too late
Okay.
for them. Sorry for
Yeah.
them.
So one thing I want to be well, okay. So let me just promote. Let me share this. So that's the first question Shafi wanted
Okay.
to ask.
On IoT-based machine learning project, say Raspberry Pi, can you give a cheat on how to use Docker for 90 base? Okay. All right. That's nice. So for IoT-based projects like NVIDIA Jetsons or Raspberry Pi, so I think the most effective way to run things on Raspberry Pi itself is to use Docker. So first thing I would advise, try to install Docker Engine, not Docker Desktop, because you are basically using a space constrained device. So use Docker Engine. Then on your Docker Engine, say you build, you of course you write your application in Python. You write all your application completely in Python. First step would be to Dockerize that your application. You would write some Docker container. You might even decide not to Dockerize it on your particular on your Jetson or your Raspberry Pi. You can Dockerize it on your own local machine or on your own normal machine, and then push it to a Docker hub. So once you push that image to Docker Hub, then install Docker. Of course, you've installed Docker on your Raspberry Pi. Pull the image into your Raspberry Pi. So that way your Raspberry Pi does not have unnecessary code. It does not store your application code. It does not contain data sets. You're saving space, you're saving resource, and it's actually the same process. So
Okay. So then the next question is,
okay,
um,
Docker Kubernetes for a beginner. How do you practice? Yeah. So, like I said, IMOX has one of the craziest craziest. Uh, it's not really a course yet, but IMOX has really good. Not their not their labs now. Yes. So this is what I'm looking for. I can share this with you. Okay, you want me to answer the image question? Oh, okay, I can do that. You can also use Code Cloud. Code Cloud also has great
cloud.
resources. There
I'll
is
I'll check for the link to the Code Cloud um course on
mm,
free code to
yeah.
share.
If you also want to learn about AWS, there's AWS Educate. Very, very nice. There's also AWS Skill Builder. Skill Builder is also very great. A bunch of them, not sure I can remember a
So
lot of them, but
Badmus is dropping now. I'll share them on the group. So please make sure you join our group. If you register for the event, I'll be sending an email detailing all the links and the link to the group. If you're not on the group, you can just send a thumbs up so I know how many people are not on the group here so I can add them to the group or share the group link in the chat section.
okay. Sorry for the image question. Somebody said I should re-answer. So images are container executables that are not yet running. So before you run them, before you do Docker run on them, they are images. When you do Docker run on them, they become containers. So an image is an executable that contains all your dependency and all your code. Then running that image is what you call your Docker container, essentially.
Okay. So, one more question. For what project level will Dockerizing be excessive? Are they free registries?
Mm, yeah, free registries. Of course, Docker Hub is a free registry. Docker Hub is, in fact, that's the most popular one. We promoted AWS ECR because this is an AWS program, but Docker Hub is the de facto and it's free, at least for, I think, for 5 images or for 5 repositories. Is Docker Hub is free. There is also GCR, Google Cloud Registry. Is it Google? Yeah, there's also GCR. Let me see. Docker Hub, GCR. I can't remember any, but those are the two de facto ones that a lot of people sort of default to.
Okay. So, any other questions? We plan to just wrap it up by 6. We spent 2 hours on
Sure.
this. You guys are awesome
What
for sticking with us.
okay? What project level will be excessive? I don't know. I think an index of HTML will be excessive to Dockerize.
Actually,
Yeah, which is exactly what we did,
yeah,
but
well,
that was just a
just a
demo.
learning. Yeah,
Yeah. But mostly Docker can be used for anything and it makes your work neat, essentially.
yeah. And people can just build your application and use it like without
Like
stress.
easily. Yep. Deployment tool. I don't know what you mean by deployment tool. If you mean Kubernetes, uh, Kubernetes is not free. There's no, I don't think there's a free Kubernetes cluster environment, but it is a deployment tool for Docker. So you can use Kubernetes. Deployment, another deployment tool can be Docker Compose. You can also use that to deploy. You can also use ECS. Can you Dockerize front-end application? Definitely.
Yeah. So like you can always dockerize anything. So the way people tend to do it is your front end may be running on one container,
Mm-hmm.
your back end on another container,
Container.
database in another container.
Yeah.
Then you use
Docker
Docker
Compose
Compose or something
to wipe it
to
together.
run all at the same time. Yeah.
I'm seeing a question about the difference between Docker and a Conda environment. As much as I know, I don't think you can share a Conda environment. A Conda environment is a dev environment for you only, but you can share a Docker container or a Docker image.
Okay. Yeah, so I think for a Conda environment, you can only share your environment.yaml file. So the person has to you share that and the person can build from it. But a Docker container, you actually have an OS in it.
Mm-hmm.
So yeah, like when you build it, there's like you're building an application containing
Everything.
an actual operating system for Conda. You don't need Conda is using the host operating system. You get
Yep.
yeah. So I I think
Mm, yeah, I think we
so.
have too many
I've
questions.
dropped the WhatsApp group, the link to our WhatsApp on the chat. I'm also going to send it to everyone who registered for this event. Okay. So one more question, and we call it a wrap. Then there are some guys I know have been very active. So if you happen to be an OAU student, you've just won yourself AWS swag. So I'm going to be announcing about 3 of them. They've been very active on on the chat, and yeah. So let's answer this, and we'll move on
Okay.
to that.
For say a front-end application environment building on different machines, how do you sub how do you structure a Docker Compose file for them? Okay, so let me share my screen. Do I? If I share my screen, it might take a long time. So let's just talk about it.
Okay.
So the trick would be, let's say you are building the front end, somebody else is building the back end. You can create, so you can have a Docker registry or ECR, two different repository, front end repo, back end repo. So when you finish building, you push to that image, you push to that repository. When the person finish building, it also pushes to that registry. Now, on the Docker Compose file, once you specify the, so there's a place for image, there's a tab for image in Docker Compose file. Once you specify the particular image that person built, Docker is going to try to pull that image before running your front end. So once you say, okay, the image is from Kende OAU Cloud Club backend, and then the front end is from Taiwo OAU Cloud Club backend. So when you do Docker Compose up or Docker Compose up, which is how you start a Docker Compose file, is to look at those two links, pull both images, and then spin them up together. I hope that makes sense for you.
Okay, okay. Okay, someone is saying we are just nine watching swag supposed to reach everybody. Okay, yeah. So let's answer this. What is the time? What's the time? We have just 4 minutes. If Badmus can quickly answer this, and
Okay.
I want to know how many people are on the call at the moment. So
Okay.
while Badmus is answering this, just drop a thumbs up so I know if I want to give everybody or just the people I singled out. Just
Okay.
drop
So
a thumbs up with your name. Yeah. So Badmus.
So Docker with AWS IoT, this is actually point to DevOps. Oh, okay. The DevOps question. DevOps is a strange concept. So say this is a starting point. It is a sort of intersection between being a developer and being an operations engineer. So whatever level of development you know now, or whatever kind of development you've done, front end, back end, database engineer, and say you have some skill as a network engineer or as a server manager or as a system admin or as a Linux administrator, if you have those varying clouds or those varying number of skill sets, you can become a DevOps engineer. So if you've done Docker with AWS IOC, yes, it's a starting point, but there's a whole lot of things to learn also.
Okay. So I guess we are at the end of this episode of another AWS Cloud Club event. I want to say thank you to everybody that joined in. We started a little bit late, but we were able to catch up, and some people stuck with us till the end. Okay,
Mm,
so um, let me see. Selecting people that are going to come for swag. So um, these three people are going to get definitely. First is drum roll, Daniel Oladende. So you must be one an OAU student and you must also be a member. So there's no way I can get to you if you're not from OAU. Second person that I'll be getting is drum roll Chinedu Edioa. I hope I didn't murder that name. So and third person that I'll be getting because I want to make it a lady, Idowu Dolapo. So I hope she's on the call. Yeah. So any other any other person that okay. So to make it very very fair and not confusing, uh, everyone that has put a thumbs up in the chat, I can see like 11 people on the call. You can always reach. You can come to AI Studio. AI Studio is just beside White House. It's a white container beside White House, and come between the hours of 12 to 3 during weekdays, and I should have something for you. One of the AWS swags. It could be a sock. It could be a pen. It could be stickers. It could be
yeah.
shirts. Depending on what you,
You like?
yeah, depending on what I feel like, depending on my mood of the day, for the day. So I want to just wrap up now because I need to even jump on another meeting. And once again, I want to say thank you. I want to say go join AWS Cloud Club's OAU. Tweet about the event. Tweet about what you know, what you learned. I'm going to be sharing every link that was shared on the group with everyone that registered. And yeah, next our next event is going to be a big one. Also, it's going to be We're going to be bringing an AWS recruiter, so stay tuned on that. So I'll be wrapping up here. Enjoy the rest of your week.
Thank you very much for joining.
Badmus.
Bye bye.